Okay, thank you. So yeah, it's a bit of presumptuous title, I guess. All about modern monitoring for both dev and ops. But I've seen like we had the modern IT stack already, so I guess that's fine to pick a title like that. Of course, in half an hour I will just talk about a tiny aspect of that. My day job is production engineering at SoundCloud. I hope you know SoundCloud. Funny enough, in Europe, often at tech conferences, people know SoundCloud because of our tech contributions to open source projects and conferences and whatever. But we are actually a music streaming service with a lot of users. You have probably used it, perhaps without knowing it. If you don't know it, ask your kids. They have used it, I'm pretty sure. And in America, it's so popular that we have now references in Hollywood blockbusters without paying for it. That's when you're really famous. Anyway, production engineering is also an interesting topic. What are we actually doing? Would be a different talk. We are doing a lot of monitoring, definitely, but not only that. And mostly, if I gave a talk in the past, it was about Prometheus. Luckily, like Victor had this nice slide with Docker and said, if you don't know what that is, you are living in a different universe. I kind of like to say the same about Prometheus by now, and given that like every other talk mentioned Prometheus, it's kind of true, I guess. So I've been a Prometheus developer for quite some time. I have given a lot of introductions to Prometheus. My colleagues have given a lot of introductions to Prometheus, so I decided to not give an introduction to Prometheus here because some of you might be bored. Some might not, but this talk will also be interesting whether you know Prometheus or not, because I have decided to pick one aspect of modern monitoring, which is what is this whole story about Blackbox versus Whitebox monitoring. And that's pretty interesting. It also has a relationship with DevOps or with Dev and Ops. So I guess you have an idea what Blackbox and Whitebox monitoring is, but let's just get into that very quickly. So Blackbox monitoring is for many people the way of monitoring, the only way of monitoring they know, which also relates to a classical the developers throw their product over the fence attitude, because the developers throw their product over the fence and they've never thought about monitoring because that's what the ops people do. And now you have your software and you have to monitor it. So what do? That piece of software doesn't cooperate. You send that piece of software whatever request that it would receive anyway. Like if you have a web server, you would send it a GET request and you check if you get a 200 back. If you want to do something more sophisticated, you do something special and you want a specific response back which you can analyze. So there are many varieties of that, but that's what's Blackbox monitoring. The monitored software has no idea it's monitored. You just do something with the software that the software is used to anyway. Well, whitebox monitoring means you are looking under the hood. You need the piece of software to cooperate mostly. I mean, you can do weird things like S-tracing something could be considered whitebox monitoring. But in general, you want some instrumentation in the code to allow you to look under the hood. And instrumenting code, that's something developers do. So suddenly, this is something where the developers have to cooperate. So of course, DevOps, if you have any kind of flavor of DevOps, that's really nice and supportive of the idea of whitebox monitoring. Or the other way around, if you don't have that, but you want whitebox monitoring, you will get into some kind of DevOps automatically. You can also look at tools, and Prometheus is usually branded as a whitebox monitoring system, while our classical old school representative Nagios is classical blackbox monitoring. That's not entirely true, and this whole thing is also about false dichotomies, right? So I put this old school stuff on the left, like developers don't care about monitoring, only the ops people do. Nagios is the old school monitoring system. Blackbox monitoring feels kind of old school. Now you have shiny new Prometheus. You need DevOps to get this running, and whitebox monitoring is the new hotness. But that's all not entirely true. Because we will look at this book. I mean, I've talked a lot about Prometheus, but ever since this book came out, I also usually put a reference to this book into my talks. This is because I'm biased. Before I was developing Prometheus and working at SoundCloud, I worked at Google as a site reliability engineer. So this book describes my former job. It's written by people I know. Niall Murphy is actually my former boss. So I'm biased. But after having said that, this is a warm recommendation. This also leads into this whole interesting debate: is site reliability engineering DevOps? Is it the opposite of DevOps? Is it an implementation of DevOps? That's also very interesting, would be another talk. But you can have a lot of interesting lessons learned by bigger companies, or in this case, one big company, namely Google, in the last 10 years, I guess. So they ran into problems we mere mortals run into now. So it's really interesting to learn from them. You cannot just copy them because they have a very different scale and everything, but you can get inspiration, you can learn from them. And of course, in that book, you have a lot of stuff about monitoring. Chapter 6, Chapter 10, I know them by heart. But the one thing you can learn from it, that they talk about symptom-based alerting. That's a really important thing in complex, distributed, replicated, redundant, self-healing, whatever buzzword you want to throw in systems. What is symptom-based alerting? Also, alerting can be anything. This is, some people think an alert, or some people define an alert as something that wakes you up. I would take it more general and say an alert is anything. It could be an email, a Slack message, a ticket filed. But there are the alerts that wake you up. I would like to call them pages, and pages should be based on symptoms, while causes should create tickets. Usually, most people don't have alerting systems that directly file tickets, although they should. But then it might be an email or Slack message, whatever. I just call it ticket and pages because then we know what it is. There is no misunderstanding, no ambiguity. And then there are symptoms and causes, which in the old world, they were not really different, right? If you're one Apache server that runs your site is down, then your site is down, right? So the cause and the symptom were kind of the same thing. Nowadays, you run on hundreds of virtual machines on Amazon or whatever, and if one of them is down, that's a cause, a possible cause for an outage, but hopefully your system is designed in a way that this doesn't mean your site is down. So now you have to decide, you have to differentiate between those possible causes of an outage and the symptoms. Also, your systems are so complex that you cannot even anticipate all the possible causes. So symptoms are nicer because they track what your users see, what your customers see, and you can alert on them. And whenever a symptom happens, you can be sure something is going on and the human has to interfere, and it actually makes sense to wake somebody up. Sometimes you have literally a contract. Like you have an SLA, a service level agreement, and there's written, I serve that many requests with that 99th percentile latency and that error rate. Great, you can put this directly into your alerts, and then you get alerted when you actually are out of your SLA. So you need those symptom-based alerts anyway, so you don't need to wake up people based on causes, because if the causes actually cause something, you will have a symptom and then you have pages. Causes are still important, we'll talk about that in more detail, but that's kind of the Kool-Aid you have to drink nowadays. And now how do you detect causes? How do you detect symptoms, sorry. That sounds something like Blackbox monitoring sounds like something that would be really good to detect symptoms. Because if my probe doesn't get the right response, probably I'm down, right? So Blackbox monitoring seems like all of a sudden, so the left side on my first slide where Blackbox monitoring was old school and whitebox monitoring was modern. Perhaps it's not quite right. Perhaps Blackbox monitoring is what we need, at least for pages. And then Nagios might be the unexpected hero in the modern world. Like the old man is now suddenly the superhero. I mean, for one, what Nagios is traditionally doing is not exactly what we want. Nagios traditionally takes a host and probes that host, right? You have always this host check first, and if that host pings, then you do all the other checks, like does it receive to an HTTP probe? Well, what we want for symptom-based, we want to probe our load balancer endpoint that our customer hits. And that's different. You can do that in Nagios. You have those weird hostless checks where the host check is eternally pending and then you still have service checks. So yeah, it's possible, but you notice that Nagios wasn't made for that scenario. Also, if you're in doubt, you go to the Holy Scripture, the Blue Book, and you read about it and you get some certainty, and that's what we do now. So let's check what would Google do. So they write about black box and white box monitoring, and this is what they do. We combine heavy use of white box monitoring with moderate but critical use of black box monitoring. Okay, so why do they use so much white box monitoring? The simplest way to think about black box monitoring versus white box monitoring is that black box monitoring is symptom-based and represents active, not predicted problems. Okay, so first they do white box monitoring for the causes and black box monitoring for the symptoms. For paging, black box monitoring has the key benefit of forcing discipline to only nag a human when a problem is both already ongoing and contributing to real symptoms. Cool, we got that, right? So on the other hand, for not yet occurring but imminent problems, black box monitoring is fairly useless. So what is that? We just heard about symptom-based monitoring, and now they talk about not yet occurring but imminent problems. So this is now second level of alerting philosophy, 201 or whatever. If you are able to predict a symptom that hasn't happened yet, but you are certain it will happen very soon, this is equivalent to a symptom, and it's even better. I want to get an alert half an hour before my site is down. Of course, I don't want to get alerted with like, perhaps your site is down, 10% probability or something. You want to be fairly certain if that happens. The most old school classical example is the disk running full, where you want to have some history, and that's where like time series based monitoring systems shine. If you see this disk has been written to for the last 4 hours, and if I extrapolate that, the disk will be full in half an hour. And if that is the disk that brings my site down, if it runs full, I better alert somebody before it's full, because it's really a mess to get out of that. Of course, your system should be designed to not depend on a single disk running full. It's just an old school example. A very modern example is loss of redundancy. Like you all know those quorum-based systems now where you have like your etcd or whatever. You run it on 5 nodes because you need quorum, and then 3 nodes are enough for quorum. So if one of those 5 nodes goes down, you are still safe because you still have 4 nodes and you only need 3 out of 4. So that might be a warning alert where you tell people, okay, during your work time, next convenience, you can replace that 1 node and be back at 5 nodes. But if another node goes down, now you have 3 nodes left, those 3 nodes are still enough to get quorum, so your site is perfectly up. Your users don't notice anything. But if another node goes down, you are completely down. So this is the moment where you think, okay, I want to work on a redundancy level of a certain kind, and if I have lost that redundancy level, that already counts as a symptom, although my users are still safe, and I want to wake somebody up to bring that node back. So you're getting into this thing. Google thinks in whole data centers, so they have this N+1 rule. Like if they run their service on 10 data centers and they would lose the biggest one, they still want to be able to serve the users. And so if they lose that redundancy, if they are still perfectly fine, but they lose another data center, then the site would be impacted, user experience would be impacted, so they alert on that. So loss of redundancy is a nice example here. And black box monitoring obviously don't help you because your users are still fine. So now I have my personal top 3 list why black box monitoring is not sufficient. That's a bit different. You can still derive it from the Blue Book, but I like to phrase it that way. And the one thing is, your probe is not real user traffic. That's really easy to miss. Like you have your nice black box probe, and like at SoundCloud we do our whole availability metrics, which is now our business metrics for the year and the quarter, is based on a sophisticated probing we do with third party, like there are Catchpoint and stuff. There are companies that allow you to probe from all over the world to make sure your service is reachable from everywhere. And we have a pretty sophisticated thing where we simulate a user going to the landing page, clicking a track, playing it, and if that works, we are up. Great. Sounds perfectly reasonable. But now imagine, I'm not saying SoundCloud works exactly that way, but let's imagine a track on SoundCloud gets really popular, it gets viral, millions of people in the world want to listen to it, and that track is in a certain S3 bucket, and that S3 bucket gets knocked out by the traffic, and nobody can listen to the track. Millions of people are sad. But our test track, which is super boring, nobody wants to listen to it, it's just beeping or something. This test track is in a different S3 bucket, it's still reachable, our probes are happy. We don't even notice if we just rely on that, right? Yeah, so you want real user traffic, you want to look at real user traffic, and imagine you had white box instrumentation, then certainly some parts of your systems are perfectly aware that this S3 bucket isn't reachable and they can't play the track. And you could notice if you had white box monitoring. Okay, second, long tail latency matters. Probably you have heard one of those fancy talks about long tail latency. I guess it's like 3 years or so that this has become quite popular at conferences, that people talk about long tail latency. That's something, if you have large scale distributed systems and you have them for a while, you have noticed that earlier, like bigger companies, and there are papers about that, is fairly well understood. If you haven't seen one of those talks, you should. But in very short, if you have like 10 backends for your one front end, and you have to wait for every 10 of those to come back, you will certainly hit like 90% latency. And then if all those backends have another backend to talk to, you will almost certainly hit really, really long tail of your latency. So there are two consequences of that. For one, you could design your system to be less sensitive to long tail latency. That's really hard. But the other thing is you should be really aware of your long tail latency. Average latency of your microservice is not that important. 99th latency or the 99.9th latency is important. So now how to probe that with Blackbox probes. If you are interested in the 99.9th latency over the last month, that's great, because you just look at all those probes from the last month and then you can do statistics. But you want to be alerted not after a month of being bad with your latency, you want to be alerted after 5 minutes of bad long tail latency. And now you can do the math. If you run like 1 probe per minute or 2 or 3, you probably can't probe way more often than that, unless your traffic is mostly probes in the end. And then you can do the math, how many probes do you receive in 5 minutes? How to calculate the 99.9th latency from that? It gets problematic. You want a view of, you want to measure every single request to get the long tail latency, which again means white box monitoring. So, and third thing, this is what I promised, you still need the causes, because your nice symptom-based page will wake you up and tell you you're down, or you are serving 5% 500s right now, and then you have to fix it. But why is it serving 500s? That would be really convenient to know. Oh, okay, our network load just doubled, or that switch is down, or whatever, right? All the possible causes should be there. You could just look at dashboards, but Victor told us yesterday that like you should pay Netflix or something so your employees have something to look at. I mean, I still think our wetware above here is pretty good, watching dashboards to find about weird situations there. But still, it's also nice to have little alerts that alert if something is out of the ordinary, or like the developer thought, if that, whatever, if that process is taking that much memory, there's something wrong. And you want alerts, not pages, just tickets or warnings, whatever you call it. And then it's very helpful if you have an actual outage to detect those, to find those causes and help you fix the outage. Okay, this is one thing I really like, and if you get to that level, this is super helpful. We have that at SoundCloud pretty well established now. You usually have a multi-tier architecture. If you're a microservice, you have whatever, poly-tier. But even in very traditional setups, you probably still have some edge service that takes the user traffic and distributes it to other services or other tiers. And then if you instrument, just that work here. Yeah, if you have your front-end service and you instrument that with white box monitoring, that service tracks every single request you get from the user. And then a monitoring system like Prometheus that can get the metrics from that service, you can know totally, okay, backend service A suddenly has a 99.9% latency that is increased over the last 5 minutes, or like backend service B is suddenly throwing 5% 503s. You can totally do that, you see that, and if you have proper alert routing, like you can do with Prometheus, you can actually page the service owner of A or B about that. And that essentially means you are doing black box probing of those backends with real user traffic, if you want, right? So instrumenting the front end and do white box monitoring allows you probing of backend, which nicely connects all those worlds. And this fulfills all the things I had in the previous slide. Long tail latency, real user traffic, it's all there. Okay, so now let's think a second about white box monitoring as a dev concern. Obviously, if you want instrumented code, the devs have to do it. And if you are like more or less into DevOps, it's easy. In healthy companies that have large-scale systems, instrumented code is second nature to the developers. If you go into that domain and your developers are not really keen on that, you might need some incentive to convince them. I mean, first of all, it's often a culture shock, right? If you've never instrumented your code and the monitoring always worked with some Nagios probing, why should I even do that? So the first lesson to learn here is it's super easy. Instrumenting code for monitoring, for metrics, is essentially a few lines of code, and there you are. And it has so many benefits, not only for the ops people who then can do white box monitoring, there are also many benefits for the developers themselves. Also, if you have done StudsD, which is a bit older than Prometheus, StudsD is also white box oriented in a bit different, has a different model, but it's the instrumentation looks exactly the same. It's essentially one line of code you put somewhere into your path. If you instrument your code with a certain library, you want to make it usable for other systems. So for example, if you have already instrumented with StudsD, you can use a so-called StudsD exporter to get the metrics into Prometheus. If you have instrumented with a Prometheus client library, there are many adapters you can put this into other monitoring systems. Put it into Graphite after all, to go old school again. Also, developers will very quickly realize, oh, there's a metrics endpoint on that binary, which I can use for debugging the binary. So as soon as developers see that as a new tool in their toolbox to debug and optimize their binary, they will totally be sold to instrumenting their code. That's one of the benefits where developers, even if they're not concerned with the ops part, are really happy about this instrumentation. How and what to instrument, that would be a long talk or a series of talks. So this is just giving you pointers. You can Google for all those orange words here. So I like quotes. So Peter Bergen, you might know him as like a popular figure in the Go community, also a former colleague of mine. And he had a blog post, Go Best Practices 6 years in. And first sentence, you should be instrumenting every significant component of your code base. There it is, I told you so. Okay, if it's a resource like a queue, instrument according to Brandon Gregg's use method, utilization, saturation, and error count. Now I put rate there because for a time series based monitoring system, if you count errors, you can take the first derivative because you have the time series in your database, and then it's a rate. So for Prometheus, it's equivalent count and rate. If it's something like an endpoint, instrumented according to Tom Wilkie's RED method, request count or request rate, error count, and duration. So you can Google Brandon Gregg's use or Tom Wilkie's RED, and then you will find a lot of information, more detailed information about this. You can, of course, also read the Blue Book, chapter 6, whatever. Yeah, it's chapter 6, I'm pretty sure. The 4 golden signals of monitoring are latency, traffic errors, and saturation. If you can only measure 4 metrics of your user-facing system, focus on these 4. Sounds a bit different, but if you think about it, and there's a whole section in the book, you realize they are all more or less equivalent. They are all like results of the same spirit. This is where you start instrumentation. I promise to not go into too much technical detail here, but just to demonstrate how simple it is. This is the Go Prometheus client library. By the way, this was also the start of Prometheus. So when Prometheus got invented, the first thing that the fathers of Prometheus thought about was, how do we instrument code in a nice way? And since they were into Go at that time, they started with the Go client library. And you can totally see like the heritage of a monitoring system. Prometheus started with instrumentation, and then how do we collect those metrics? What do we do with them? How do we create alerts? And then like it went down that chain, while other monitoring systems like Nagio started with, how do I probe servers, right? And then went from there to other areas. Bosun, for example, started with, how do we make it easy to have awesome alerts? So they started from the alerting part and then grew the other way. Influx started with, how do we write a nice time series database to do lots of interesting things, for example, monitoring. So they grew from that part. You can totally see where those monitoring systems started. So Prometheus started exactly here. And it's really easy. You import that package from the library and you add a handler on an endpoint, which is by convention /metrics, but you could pick whatever you want. Usually in a microservice environment, all your binaries have HTTP servers anyway. If that's not the case, it's a bit more of an effort or more of a change. But yeah, and at SoundCloud, everything is a microservice, so it has those endpoints anyway. And then you have that metrics endpoint. And if you go there, you can go there as a human to just learn about the binary. You have done nothing else but these 2 lines, and then you get already gazillions of metrics about the Go runtime, garbage collection, number of Go routines, but also down here, like process metrics. How much memory is your process taking right now? That only works on Linux, but who uses anything else in production? And this is already, you have done nothing. It's so valuable in your dashboard, in your monitoring system. If you have an outage, let's just check, oh, that binary just suddenly takes twice as much memory. Oh, interesting. Or Go routines have exploded, for example, or garbage collection stops, whatever. Like there are already so many valuable pieces in there without doing anything. What you really want, of course, you want read method, use method, 4 golden signals, so you can create metrics like a histogram of latency or like a counter. Here's a dimension by status, HTTP status code. That's also the heart and soul of Prometheus, to label everything like Kubernetes. And with that one, you put this line, I mean, it's semantically essentially one line, which means whenever this function which handles an HTTP request exits, I observe the time that has passed and I count by status code, and there we are. And then you get interesting metrics, which already allows you all this stuff with error count and latency, and it's really simple. So this is my last slide here. This is an example how developers will like instrumentation, because when we developed the Prometheus server and we were the people who told everybody to instrument your code, we of course instrumented our own code as well. And then, and this is just beautiful. I mean, it's pretty old. Prometheus works differently now internally. But when we developed the storage layer and you had certain storage operations and you just instrument them and then you can plot them. And like this is like alive, right? This is heartbeat or whatever. You can see what operations the storage is doing. And it's so helpful if you want to understand as a developer, how is that going? Is it going as expected? And you see which operations are happening when. And this is like, you would start step-by-step debugging or S-tracing or whatever, like all those tools that are great, but like the metrics are already there. You need to instrument anyway for monitoring later. And then you can just point your Prometheus server at it, draw those graphs and get a lot of insights. That's really cool. Okay, so this is our Prometheus project page. This is my own repo where I put all my talks. So I will also link the slides so you can look at them. I think we have, perfect timing, 30 minutes. So we have plenty of time for questions, but for now, thanks for your attention. And that's it.